So Chapter 1 should mostly be a review of concepts you've already seen before, either in chemistry or biology. There might be a few new terms, but hopefully most of these look pretty familiar. So in chemistry, what we're going to be talking about is two different things. We're going to be talking about macroscopic topics, which are things that we can see with our eyes, and we'll talk about microscopic topics, things that are too small to be seen without a microscope. In our case, microscopic things might even be too small to be seen with a microscope that you've seen in like biology class. It might be something like an electron scanning microscope, which is which is about the size of a room. So we'll be talking about things we can see and then things that we can't see. So we're going to be making observations this semester. Two types of observations. Qualitative observations are descriptions. These are things that we can make with our five senses, how something smells, how something sounds, how something feels. So color, texture, things like that. Now, what's really important to remember about qualitative observations is they are subjective. So if I'm doing an experiment with a group of people, I might say something turned blue. Somebody else might say it was turquoise. Somebody else might say it was baby blue. So we can disagree on a qualitative observation. However, a quantitative observation is a measurement. This is not subjective. It will have a number. If I measure something, then everybody in my group should agree that I have 25 milliliters of liquid, or 72 degrees outside. Now, qualitative, I can say 72 degrees out is hot. Somebody else in my group could say 72 degrees is cool, but we're both going to say it's 72 degrees. So that's the difference between qualitative, which is a description, and quantitative, which has numbers. Okay? Now, we're going to make observations. We're going to formulate hypotheses. Now, when we talk about a hypothesis, it's a possible explanation. Now, you've probably been taught before that a hypothesis is an if-then statement. The hypotheses that you're going to be writing for this class are going to be much more in-depth. The reason it's going to be much more in-depth is it's based on background knowledge and research. So you're going to have to explain your background knowledge and research before you can make your explanation. You're not going to just say, if I do this, then this will happen. You'll need to say why that should happen. Okay? We will be performing lots of experiments in this class. Now, why we perform an experiment is to test a hypothesis. Now, when we perform experiments, they can support or refute hypotheses. They cannot prove hypotheses. And the reason they can't prove hypotheses is because somebody can always perform another experiment somewhere down the road and realize that it's wrong. I can have lots and lots of experiments that support it, but all it takes is one to disprove it. Okay? So, theory is a word you hear a lot these days. Now, when we talk about theories, people think that it just means it's an idea. It's kind of the same thing as a hypothesis. It's not. It's based on hypotheses that have been tested and tested and tested. And what it's going to do is it's going to give us an explanation of some type of phenomenon. So for example, we've got the theory of gravity. Now, when I say gravity, everybody says, oh yeah, gravity's a thing, it exists, but that's because we've tested it and tested it and tested it. So theory doesn't just mean, oh, it's somebody's idea of what should happen. It has to be based on lots and lots of tests, okay? Now, when we talk about observations versus theory, an observation is something that can be witnessed or something that can be seen. So an observation is, I performed this experiment, I saw it turn blue. I performed this experiment at 72 degrees. I saw this happen. Now, a theory is an explanation for why it behaved this way. Why did it turn blue? Why did the temperature go up to 72 degrees? But the theory is going to say why it happened. Observation is just, I saw this happen. Theory is, why did it happen? Okay? And it's really important that you remember, theories change as new information becomes available. So, our theories are never permanent. I can do a million tests to support and support and support, but as the equipment gets better, as we do more research, it's always going to change. Okay? Now, a law is different than a theory because it is saying what happens. It does not say why. So the example of a law is the law of conservation of mass. This says that if I perform an experiment, the starting mass at the beginning is going to be exactly the same as my ending mass if I add up all of my products. My mass can't go away. It does not say why. All it says is that matter can't be created or destroyed in an experiment. No explanation. Theories are why. Laws just say what happens. Okay. Now, in this class, we're going to be using measurements based off of the SI system, or the international system. We'll also use metric measurements. We won't use English measurements. So the SI system is a little bit different than metric. In metric, it's grams, liters, meters. SI is a little bit different. If you notice, mass is in kilograms. Now, we'll still usually actually use grams in here because we won't ever have a kilogram worth of chemicals. Length are still meters. Time is seconds. Temperature is Kelvin. Now, we will use Kelvin in this class. We will also use Celsius. We will never use Fahrenheit. We'll use moles. We won't really worry about amperes or candelas. Those aren't things we really need to know about. Okay? Now, when we're talking about our units, volume is how much space something occupies. Mass is the amount of matter. So, for example, when I talk about volume, I can buy 2 liters of soda at the store, 2 liters of Coke, 2 liters of Pepsi, but I'm talking about how big that container is. When I talk about mass, it's how much stuff is in that container. Now, another definition that your book gives you is the force necessary to give an object a certain, acceleration. This is the physics definition. We won't really use that. Okay? The book talks about it. You might see it places, but that's not really what we care about. What we care about is the fact that it's how much stuff is in an object. Okay? Now, usually people use the word weight and mass interchangeably. They are not the same thing. That's what that little not equal sign means. Weight depends on gravity. Now, if I weighed myself here, I weigh myself in Lake Louisiana, it's not going to be exactly the same. For me, that change isn't going to really matter because I have a pretty big mass. But if I was weighing, say, 2 grams of a chemical, that difference in weight would matter. So when we actually weigh something on a chemical balance, what it does is it compares the mass of an object to a standard weight or a standard mass. So the scales have actually been set so that they weigh things and then they compare it to the standard. So 2 grams here is the same thing as 2 grams in Louisiana, is the same thing as 2 grams in China, is the same thing as 2 grams in Australia. The weight needs to be the same as the mass, because otherwise, if I weigh out 2 grams, it's not going to be the same thing. Okay? So we're going to talk about weight versus mass, but we can technically use them as the same term because when we weigh something, the mass isn't going to change in our classroom, but know that they're not actually the same term. Okay? So hopefully these terms looked pretty familiar. I went through them pretty quick, but we should have these in our head. But that should be it. Make sure you know the difference between those terms.